the latest prototype I've been working on. This is, I've been using, I don't know if any of you cruise around on YouTube with the, looking for some of the stuff that gets a lot of the hits as far as magnet motors, but this is originally designed by James Roney, and using one of his James Roney Stators that he actually names his website and YouTube channel after. I've actually, James, if you're watching this, I've actually made quite a few of these over there. I've got about 7 of them now because I want to hopefully mount the stators right round the wheel. This, of all the things I've made so far, has definitely been the most promising. This, of all the things I've made so far, has definitely been the most promising. I haven't got my placement as good as James does on his. I can see he gets a lot more pull down in towards the stator. But anyway, this is yeah, it actually accelerates past the stator, which is amazing. Accelerates past the stator, which is amazing. As you can see, it sort of pulls the magnets in and then accelerates out the other side.
How's it going, everybody? So tonight I did a copy of the James Roney one-way magnetic stators, and I copied everything to what he did in the videos, except I used a higher grade metal. You can see this is the ABS and the juice can lid, tape, that silver part made with a little bit of iron and molybdenum, I think the name is, but I ordered it from a magnet company explicitly made for magnetic shielding. These guys do exactly what he showed in his videos. These guys do exactly what he showed in his videos. It's crazy. These were N42 magnets, the ones he ordered, the 1 by 2 by 1/4 inch. And with this type of shielding, the batteries and the plates, there's no magnetic attraction, but yet you flip it around, yeah, definitely magnetic attraction. You hear nothing. It's just amazing because even though there's a little space in there, the same amount of room to burst. A lot of strength there, a lot of strength there, but yet when you put it end to end, there is nothing. I would rate this as a tremendous success on his part of figuring this out. I would rate this as a tremendous success on his part of figuring this out. All in all, I'm really impressed with how this came out.
Hi guys. This is in response to what I refer to as a very irate YouTuber. These talks about the last video I put up, or the video before the other video I just put up, actually. This gets confusing. But there's a video put up here that you'll find a comment with lots of exclamation marks under it. And he was pissed because I did not explain in any kind of detail what was going on here. In fact, he accused me of not even knowing what the hell I'm talking about. I don't even know what's going on. But to be honest with you, to this very day, no one truly knows how magnetism works. The real secrets of all of magnetism is still yet to be unlocked, if you will. So he made a good point, though. This is my backup channel. I have a primary channel with the same exact name, but there's space in between the letters. In this channel, there's no space in between the letters, but the name is duplicate. It's the same name. So on that channel, I do go into detail, but I don't know how well those videos explain what's going on here because I made those videos years ago. So I'm going to do it again here. This time I'll make sure I'm very thorough. So if you want to know how my stators work, you're in the right place. If you don't really care about how all of this stuff works and why my wheel does what it does, then it's probably best to click out now because I'm going to go into great detail why this works. It's very important that this knowledge becomes widespread and not scrubbed from the web. But I'll give you a quick little demonstration again. That what we have here is we have a magnet here on the wheel. It's a neodymium magnet. It's round and it's 1 inch by 1 inch, solid, no hole in the middle. And then inside this stator, we have hidden a 2-inch by 1-inch by 1/4-inch magnet, which you'll get to be able to see completely with no box around it in just a minute. Okay, so the premise behind why this does what it does is because the attraction between a magnet, let me grab a magnet, here we go, use this one. Okay, here's another one of those magnets on the wheels. Okay, this is a piece of steel. The attraction between this and steel is nowhere near the same power of pull or attraction as it would be if I got another magnet and put it next to this one. I'm not about ready to do that because, one, it'll slam into this magnet really hard and potentially can blow up in little pieces. There's no explosion, but it just shatters. And two, once I put another magnet on this magnet, it is an absolute nightmare. I repeat, it's a nightmare to get them separated because I don't have a proper separation setup to separate magnets. I'm setting up a new lab. So eventually I have an easy way to separate these. But magnet to magnet attraction, when you have one magnet next to another magnet, is real powerful. I mean, it's ungodly powerful. So, and once you get so close, it just like sucks it in. Of course, it's not sucking, but the pull of attraction gets real powerful in the last 1/2 inch. When you have two magnets, that's within like 1 inch. They just want to slam together. Okay? But when it comes to metal and a magnet, separating them is pretty easy. Even if I get a chunk of steel here, I don't have any in the room. But it's the attraction from a magnet to steel is not as great of pull power. I can't say attraction because the steel itself, or the metal, doesn't have any attraction. It doesn't have any magnetic properties. It's just the magnet being attracted to the metal or steel. Okay? But another magnet being attracted to another magnet is extremely powerful, like I just said. Now, this is exactly why this works. What I'm doing is capitalize on the difference between the two strengths of pull. The difference in pull power or attraction between magnet to metal or magnet to magnet. I'm not going to bring out another magnet because I don't want any accidents. I have to be very careful just holding this here close to this stuff. Okay, so let me set this down before I have an accident. Okay, so the whole premise why my stators do what they do, and we're going to break it down. You're going to look inside these stators and you're going to see what's going on, is that this magnet here is doing what? Either side will do what? It'll attract to steel or metal, any kind of magnet, any kind of metal that's, I forgot, there's a technical term for it. I just don't remember what it is. But any metal that has magnetic properties to it that will attract magnets. So what's going on here is that we have a magnet to steel. Actually, this is some kind of tin, but I'm sure it has steel in it. Tin is a mixture of alloys. But anyway, this magnet is attracted to this metal. However, on this side, we have raw magnet. You can't see it because it's covered in foil. You'll get to see it in just a second. So when this backside of the magnet comes around, I have gone on ahead and set this to repulsion. So these are like polarities. Now, I don't know which polarity it is. My polarity tester has disappeared. I've ordered another one. It'll be in here any day. So whatever polarity this is, it's really irrelevant. The fact is that this polarity and this polarity here are identical. So if it's north, then this is north. If this is south, then this is south. In any case, what happens is that like polarities do what? They repel. They push away from each other. Okay? Versus on this side, we're not looking at the raw magnetic field because there is no magnetic field back here. I've canceled it out through this housing that shields or shuns the magnetic flux from radiating outwards, which changes everything. Okay, so this magnet is attracted to the metal. As it gets attracted, it then pulls over the faceplate. And this is not angled very well. This needs to be tilted more, because when a magnet comes closer to something, it's attracted to the closest point. That's why the V-gate does what it does, even though V-gates don't seem to be perfect. They don't seem to work right. Like lightning, it strikes to the closest point. Well, magnets are attracted to the closest point. So when this is tilted a little bit more this way, I could actually move it, but I could, like that, then this metal here, a magnet's going to be attracted to this metal, is going to accelerate it, cause it to accelerate. What happens is this is so important. We have in the wheel what we call inertia or momentum. And as this accelerates and comes into the stator, the momentum and its inertia takes it past the edge right here of the stator. Okay, there's an edge. Let me pull this down here. Whoops. Okay, make sure I don't get the phone too close to the magnets, otherwise it screws up the recording. Although it doesn't, this phone here doesn't seem to be as sensitive. My old phone, iPhone 7, got it anywhere near a magnet. It went crazy. It started doing weird stuff. And I put it up anyway, but people think I faked it, and I should never have posted that video called Magnet in the Paperclip. Anyway, this edge here marks the beginning of where this raw magnet here can be easily seen as far as an angle of approach. Really needed was a drinking straw or something non-magnetic to show you what's going on here as a pointer. I'll try using this. Okay, so what it is here, we have this edge right here. Okay, and the raw magnet, it's not shielded. That's just aluminum foil. I peel that off, it'll just see a magnet there. Okay, and what happens is, as this magnet swings, now we can't see the magnet. There we go. As this magnet here swings past, I call this a faceplate. This is like a plate, which is not, it's just a box. Faceplate's a technical term used in this industry, a lot of industries. And so, as this magnet swings past it, it's now seeing the repulsion mode. I can feel it already trying to pulse out of here. Push out, watch. If I let go, watch. See? So that repulsion mode starts right about here in the middle of the stator. Right about that center in the middle. Isn't that interesting? But right there in the middle. But before the middle, it's pulling towards the stator and then pushes right on through. Now, if I try to go backwards, watch what happens. Yeah, it went through anyway because it was too fast. You go backwards a little bit. See? It doesn't want to go backwards. Yet, if you go the other way with just a little bit of spin, it wants to go right on through. And it actually gains speed on the way out. That's not supposed to happen, supposedly, based upon Newton's third law, which I think is just a fallacy. Okay, because I have a magnet on each side here, you can't see. Okay, there's one here, and there's one here. So there's one and one on each side, okay? My phone is fastened down to a stand, so I can't just pick it up and show you closer. Okay, so exactly how and the design of why this works is important, besides just telling you that it works upon the fact that this side doesn't have any magnetic properties. Because if I hadn't shielded on this side here, let me show you here. If I hadn't shielded this, then we would have magnetic attraction. We'd have magnet-to-magnet attraction. And that would cause a really bad counterpull. And Newton's third law of motion would be taken over. Okay, so now I may get interrupted here in a minute. I may have to cut the footage and resume here, but let me continue. Okay, so on the back side of this here, so it's only metal to steel, magnet to steel attraction. What I've done is that I have made it so there's no attraction. See, oops, There's no traction and no traction on the face here. The traction doesn't start until you get over here. And of course, then the screwdriver sticks. Okay? But from about halfway this way, there's no traction. And you can feel the traction starting to begin on this side, which is the side that pushes the armature magnet. That armature magnet right. Dang it. This armature magnet, it's called an armature magnet. It's on the armature of this wheel, and there's the magnet. Okay? So, this way, as the magnet approaches, it's not seeing any magnetism. It's only seeing steel. So what we have is magnet to steel attraction. And then on this side, we have the raw magnet. Now, let me put this down and out of the way. And I'll show you what's going on closer up. This is just a simple, everyday metal box. The idea is not original. I learned this in a 7th grade science class many, many years ago, many moons ago. And so all I did is I've applied this differently. I've taken this concept to a whole new level. That's all I've done. So I'm not doing anything crazy or weird. So I'm simply using the box to shun the magnetic field. So this is the first one I ever built. It doesn't work all that well. It was just an experiment. So what it was, I decided to make a better one. So I made this one. This one didn't work that much better either, although it's a little bit better, not by a whole lot. Then I made a little bit bigger box so the magnet wouldn't be so close to the edges of the box. But at the same time, I was losing the focal point of the flux coming out, because one of the things I learned by doing this, taking turns of a barrel or focusing, I'm focusing the flux like this versus it being wide open like that. So when you set the magnet back into the housing, then it makes it so it doesn't curve out real fast. It gives it more of a focus. Okay? But unfortunately, it's just one layer. I go, okay, we need to get more control over the back because we still have magnetic properties on the back. It's not bad, but it's not good. So then I devised a more thorough method. And that's when I put a box inside of a box. And that worked beautifully. Now, you can't have... Great. Dang, that's hard to get out. The magnetism. Okay, you can't have the metal touching the metal. Everything has to be separated. So when you build one small box, there's a 1/4 inch separation there. And it's not quite a 1/4 inch separation on the ends, but it's close. Okay, and then you put spacers in here, 1/4 inch, and then you drop this in there. And then I did a total of 3 layers. And then that came out to be this. I did a real compact one. So that's how we have this. Okay, so that's what's going on here. So this here is what you're seeing here. It's just covered over with aluminum foil. All right. So now, as far as the magnet itself, as you can see, I'll take one of these apart. What's going to have to happen? Let me take... I guess let me take the first one apart that I ever built. Okay, so you can see what's going on. Gotta pull the magnet out. Here it comes. Just about got it. Almost. Okay. Trying to go back in. Okay. As you can see, it's just a box. And the magnet was just laying in there. That's all. See? That's all it is. It's 2 inches by 1 inch by 1/4 of an inch thick. Okay? I don't want to get this too close to my phone because it might screw up my phone. Let me do this. Okay, now you can see. Okay, so that's all it is. This is neodymium N42. It's N as in Nancy 42. That's the strength. Alrighty, so, and then what's happening is that I set this up and lay this in there. So when the face of this is going to help attract this. Oops, got the face wrong. Okay, hang on a second, let me back this up. Let me go to wide angle again, there we go. Okay, so what happens here is that, oops, there we go. Oop, gosh, almost got away from me. This is powerful stuff, I have to be real careful here. I got the magnet in my hand, as you can see. And as you can see, as I let go of this, it pulls it. But guess what, guys? It doesn't want to go past it. We have what? A sticky spot. Okay? So it doesn't work. But what if I was to shield the back side of this magnet so this magnet didn't see this magnet until this magnet has gotten to here? Then it would do what? It would push it away. See? Pushes it away. See, it wants to push. So, but we have a double sticky spot. Sticky, it doesn't want to go through this way, and it doesn't want to go through that way. See, it keeps going the other direction. Back up so you can see better what's going on. Okay. Okay, there we go. Okay, so let's do this again. Okay, so what we have here is we have a sticky spot here and a sticky spot here. So let me push it. It's not going to go through. It's going to take a lot of power. Ooh, I push it so hard, but it wants to stop there. And if you go over here, it wants to stop here this way as well. Oops, I pushed it too hard. See? So my box, though, resolves that. So we don't have a sticky, we only have a sticky spot going this way. But we don't have a sticky spot when this armature magnet goes this way. Okay? So that gets back to this. Let me put this down somewhere where it doesn't do something wrong. Okay. So now we'll go back to this box here that's built really nice. The magnet is laying down inside here. Remember, there's no attraction on the back side, which means we're not going to set up a sticky spot with the magnet coming from this direction. Okay? See if I got this facing right. Nope, I gotta flip it. Okay, there we go. Okay. Instead of holding, let me just put this back down here now. Okay. So watch it. Go this way. It still has a sticky spot. Okay. But if we go the other way, oops, I didn't push it hard enough. The sticky spot is gone. There's a slight, I mean, ever so slight little stickiness to it, but it's so little. But nothing compared to this in this direction. And that's what you're trying to do. You want to create an imbalance. So if I had to guesstimation of the difference in the stickiness, because there's a little bit of stickiness here. It's not zero, but it's damn close. And when time you add up more stators, it cancels all that out because it just sucks it in and pulls it right on through. Look at the other video, 2 videos before this one. So anyway, so that's how this works. There's very little magnetic to magnet attraction here. It's mostly magnet to steel. If I had to guess at it, I'd say it's like 80% attraction. To the attraction is 80% based upon the steel, not the magnet. And then as far as any stickiness is concerned, because some of this is looping back a little bit, just a little bit. It is goofing with it. Probably can be improved. But on this side, it's like the repelling force I'm talking about 80% cancellation on this side, and this is like through the roof on this side. This is just a raw magnet. So anyway, so we have magnetic cancellation here, almost completely all of it, because I can do this. There's just really nothing there. And on the face, it's almost nothing there. That's what's going on here. So the face has some magnetism getting through it, and that needs to be improved so this magnet's not bleeding through to here. And that's what's going on. That's what's causing a little bit of drag here when it comes in, like this. Okay, it went through anyway. But if you go backwards with it, it doesn't want to stop. It's a little too fast. Yeah, it went through anyway. Okay. But you do that on the other side, about the same push, and it wants to go all the way through. It didn't quite make it. I'm not pushing it hard enough. There we go. But on this side, you can be more aggressive with it, and it'll still stop it. But on this side, you just give it a little push, and it'll go right on through. And it actually picks up speed. Did you notice that? See, it picks up speed. See, it's faster when it comes out this side, and it's slower when it comes in. See, that's a good example there. Okay, so that's how my stators work. More repulsion and less counter attraction. I'm not sure if I explained this right. I'm tired, but by demonstrating this, hopefully you get what's going on here. So what it is Newton's third law of motion says for reactions equal opposite reaction, which means this. It means that supposedly this comes here, it wants to go through, stop, come back, go through, stop, come back, go back and forth, like a pendulum. And then eventually we'll find an equilibrium in the middle. It's not doing that. This is not balanced. It just isn't. And I've capitalized on that. So that's why this works the way it does. This video's gotten way too long. I assume that maybe you're still sitting here with me. But here nor there, that's what's going on. And hopefully this gives whoever wants a completely lengthy explanation in great detail. That's how this is done. You just want to make these boxes tolerant, tight, really tight tolerance. So it's really compact. So the next box is still compact. And then the next box on top of the box is also compact. Otherwise, this gets to be really bulky. That's it. I don't know what else more to say. I'm not a mathematician, so I can't explain this to you in math. I don't think it's necessary. This is done in the layman's terms. So anyway, hopefully whoever needs to know more detail, then hopefully this will solve it. And just while I'm at it, this is what I'm using here. I got this stuff at Lowe's. It's just tin flashing. I think it has an inventory number on it somewhere. I'll take it apart here. We'll see here. But I set this up for demonstration. Forgot all about it, at least almost. Okay. So you can see here, I got 1/4-inch spacers in it. And you can see the magnet, the magnet doesn't really attract the screwdriver. Okay, so that's how I'm doing this. Now let me take this apart and give you an inventory number. All right. Here are your inventory numbers. This is just let me zoom in. It's not enough. There we go. And one of the numbers is a little hard to read, so let me show another one. Yeah, it's a little easier to read. And there's one more here, so I'll show the third one in case, this one's even worse. That's all torn. But anyway, that's what I'm using. And I don't have enough of this stuff to keep building my stator, so I'm gonna have to get more of this. I bought this stuff a long time ago, so I don't even know if I can still find it. Anyway, hopefully I can. that's it. Hopefully this answers some questions. Alrighty. This is my backup channel. Go to the other channel. I'll put a link on this underneath this description. It goes to the primary channel. You'll find hordes of videos on this, all kinds of stuff. Way back in the early days when I was first starting to do all of this. And some of it just kind of haphazardly put together, but still shows what was possible. And now we can see, yeah, I think we can get a motor running strictly and only through magnets. But there's some out there who say otherwise. Those are the same people who said we couldn't get to the moon. They are the same people who said we would never fly. Of course, now we have airplanes and now we have rocket ships. So, and we also said we'd never be able to tread Earth gravity. We'll never be able to defy gravity. Now we have UFOs out there that defy gravity. So a lot of things that people say can never be done later are proven to be done. And Stephen Greer does say that there is truly free energy devices out there. I don't care what your opinion is of him. It's irrelevant. But there are answers out there. And somebody like me who's just an amateur at this, I'm just trying to see what's possible. And if I can get this to working with some nice torque, we can convert that torque to electricity. This is just, all this is about proven theory. When an actual model will be made, I won't be using no bicycle wheel. I'm just using a bicycle wheel just to test to see if what I'm doing has any merit. Is there any validity to what it is I'm doing? And surely enough, go watch the video before this one. You'll see there is validity. See, I kicked it out. Watch this one. You see it's even fast. It comes in slower and kicks it out even faster. See? So when you have multiple stators, one here, then here, and here, and here, all the way around, it'll kick it to the next stator, and kick it to the next stator, and the next one, the next one, the next one, and passes it on down the line. Kind of like a leapfrog in effect, if you will. Okay, I am really tired. I gotta stop making these videos late at night because it's hard to think and talk clearly. So I've done my best to try to enunciate my words so I can be easily understood. Alrighty. Thank you again, guys. Take care. And the next update, hopefully it will be a huge update. Take care. Bye-bye.